Hello students and welcome back to my channel. I am today again with a new video. This time I have picked questions from current electricity which were asked on 30th January 2023 JEE mains. Right? So without wasting time, let us start discussing them one by one. In the following circuit, the magnitude of current I1 is, which is I1 see. You have to find the current I1. Now two cells are there here, you can see. So the usual method, as you will find in books and most of the teachers will tell you, to use Kirchhoff's both the laws. First, by virtue of Kirchhoff's first law, you have to distribute the currents, and currents are already distributed probably. You may use Kirchhoff's first law to eliminate any one of the three currents, and then apply Kirchhoff's second law or the loop rule to form equations and then solve. Naturally, it will be tedious and it will be cumbersome. So I personally feel there is yet another technique in such cases to apply. That is known as principle of superposition. So if you apply principle of superposition, you will get the answer very easily. So the principle of superposition states that you keep one battery at a time and short circuit the other batteries and find the currents on all the branches. This way you do for each cell. Keep one cell at a time and short circuit rest all the cells. Short circuiting means just remove it and establish a direct connection across the terminals of the cells. And then this way you get the currents. So once you get the current, you can superimpose them. That is, you can add them algebraically. If the currents are in the same direction, you simply add them. If they are in opposite direction, you have to get the difference. You have to subtract. Okay. So let us solve this question. So first I am going to short this cell. Okay. Now when I short this cell, okay, just I establish a direct connection. You can see that it is just like a balanced Wheatstone bridge. Okay, because 2 upon 1, here also 2 upon 1. So when P by Q is equal to R by S, then these 2 points will be equipotential points and no current will flow through this. So in such case, there will be no current here. So the current starting from this will flow this way. This current will come this way and this current will flow this way. And in other words, this 2 ohm and 2 ohm are in series. This 1 ohm and this 1 ohm are also in series. So let us find the current through this 2 ohm, 2 volt cell. So 2 ohm and 2 ohm are in series. So effective resistance is 4 ohm for this branch, and for this branch it is 2 ohm. So the effective resistance will be 4 into 2 upon 4 plus 2, that is 4 by 3. So current drawn from the cell will be voltage of the cell, that is 2 volt, upon effective resistance between the cell terminals, which is 4 into 3, that is 3 by 2 ampere. Now next what we have to do, we have to short circuit this cell and we have to retain this cell. So I'll redraw the figure once again. Okay, we have to short circuit this. We have to, in other words, we have to establish a direct connection between these 2 points. So these 2 points remain connected. So the this 2 ohm I'll draw this here, this 1 ohm I'll draw here. Again there's a cell here and 1 ohm resistance, 5 volt cell is there. Then since these two are connected, so you have like this and again like this. Okay, so there is no current flowing through this, as you can see students, because whatever current is coming out through this, now say the current will be equally divided in these two, and the same current will be flowing through this. In other words, the current flowing through this 2 ohm will flow through this. Here that is this 2 ohm and this 1 ohm, and the current flowing through this 2 ohm will flow through this 1 ohm. That is, these two are the things. So there is no current here because anyway it is shorted. So there is same potential. Potential will be same, so there is no current. So that means there is no current here in the second case. Now superimpose both the currents. In the previous case, we got a current equal to 3 by 2 ampere in this branch, and then in the second case, we got 0 ampere. So final answer is 3 by 2 ampere. After superimposition, we got this. So 1.5 is the answer. I don't know how, whether it is integral or not. I'm not sure. It should be integral, and we are not getting an integer. It is 1.5. Right. Moving on to the next question. The charge flowing in a conductor changes with time t as q equal to this much, where alpha, beta, gamma are constants. Minimum value of current. We'll be applying the concept of maxima and minima. So first we'll obtain the expression for current, which is nothing but dq by dt. So as you differentiate them, if you differentiate this with respect to time, you'll get alpha minus 2 beta t minus, sorry, plus 3 gamma tq, t square, sorry. So for maximum or minima, the derivative should be equated to 0. So for minimum or maximum, I, di by dt should be equated to 0. So once again you have to differentiate this. So when you differentiate, you get minus 2 beta plus 6 gamma t is equal to 0, and you get the corresponding time as 2 beta by 6 gamma, that is beta by 3 gamma. This is the time corresponding to which the current is minimum. Current has to be minimum. You can see if you differentiate once again, you are left with a positive value because they are clearly given. Gamma must be positive. You are left with 6 gamma when you differentiate this once again with respect to t. And since d2i by dt square is positive, so this must correspond to minimum value. Now you need to substitute this here. Okay. We want minimum value of I. So I as a function of time, just substitute them. So here minimum value of I we can obtain like this: alpha minus 2 beta into t. What is t? T is beta by 3 gamma plus 3 gamma into t square. T square is beta square by 9 gamma square. So here a 3 gamma gets cancelled here, and we are left with alpha minus beta square can be taken common, and we are left with 2 by beta square by gamma can be taken common. 2 by 3 minus 1 by 3. So this will be alpha minus beta square by gamma. Okay. Moving on to the next question. The equivalent resistance between A and B is. So here these two are in series. These two are also in series. Okay. These two are in parallel. These two are in parallel. So let us redraw the circuit diagram, keeping in view all these things. So here the equivalent resistance is 1.5 plus zero point 0.5, that is 2 ohm. This is 12 ohm. These two are in parallel. These two are also in parallel, which in turn is in series. So parallel means product upon sum. Equivalent resistance for this will be 8 into 2 by 10. Whereas here it will be 4 into 6 by 10. And then you add them because both are in series. So 16 by 10 and 24 by 10. 16 by 10 and 24 by 10 ohm. That is 4 ohm. If I'm not wrong, 16 plus 24 is how much? 40. 40 by 10, 4 ohm. Then we have 6 ohm here. And finally, 1 ohm and 1 ohm in series, 2 ohm. So as you can see, all these are in parallel. Okay. So we can directly apply the concept of parallel, or step by step we can eliminate, not a problem. So for example, 2 ohm and 2 ohm in parallel will give you 1 ohm. Okay. Then 12 and 6 in parallel will give you 12 into 6 upon 12 plus 6. 12 into 6 upon 12 plus 6 is 18. 6 is a, these two in parallel will give you 12 into 6 upon 12 plus 6. 6 is 18. 3 fours are. Now this 4 ohm and 4 ohm are in parallel, so they will give you 2 ohm. These 2 and 2 will give you 1 ohm. So finally we have 1 ohm and 2 ohm in parallel. Okay, so effective resistance will be product upon sum. So product is 2 into 1 upon sum. So 2 by 3 is the correct option. If you have any problem, you can go with the usual technique. The general formula is 1 upon effective resistance. If resistors are in parallel, you can go on applying this 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. Anyway, you get the same result. Then coming to the next question. If the potential difference between B and D is 0, the value of X is 1 by N ohm, the value of N is. Now students, you see B and D is, they are equipotential points. That means it's a balanced Wheatstone bridge. If you connect an ammeter, it will show zero reading because the points B and D are at equal potential. So there is no potential difference. In other words, ratio of these two resistors should be same as ratio of these two resistors. First, let us find the equivalent resistance. 3 into 6 into 3 upon 6 plus 3. That is 2 ohm. So we have from principle of Wheatstone bridge, this is 2 ohm and this is 3 ohm is equal to, this is x upon 1 plus x upon x. Okay. Assuming x not to be equal to 0, we can cancel it. So finally we have 1 plus x is equal to 3 by 2. So x is equal to half. In other words, n is 2. N is 2. That's all students in this video. Thank you so much for watching my channel. Please subscribe and hit the like button. Thank you.